Okay, we have this fraction, 4 over the square root of 3, and we are going to rationalize the denominator. Rationalizing the denominator just means that we want to rewrite this fraction so it is the same thing, but with no radicals in the denominator. Okay, and the reason we do that is so that we can have a standard way of writing these fractions so that we can compare answers, etc., and it'll just be in the same standard canonical format. Okay, so the way to undo a radical, or to get rid of a radical, would be if we squared it, right? This is the square root of 3, so the opposite of the square root is squaring it. So we want to square this, and we can square it by multiplying it by itself, right? But if we multiply the denominator by the square root of 3, then we're changing the fraction, and we don't want to change it. We want to keep the exact same fraction, but we want with no radicals in the denominator. So if we're going to multiply by the square root of 3 in the denominator, we have to do the exact same thing to the numerator. That way we don't actually change the fraction. So we can multiply this fraction by 1, right? Square root of 3 over square root of 3 is just 1. We can multiply anything times 1, and we're going to just end up with what we started with. So this won't change the fraction at all, but it'll just put it in a different form. So in the numerator, we'll have 4 times the square root of 3. And in the denominator, square root of 3 times square root of 3 is 3. And there we go. We have the same exact equivalent fraction, but now with no radicals in the denominator. Okay, let's look at this example from Math Excel. We have 6 over 1 plus square root of 2, and we want to rationalize this denominator. And the way we will rationalize this denominator is actually to use a difference of squares. If we use a difference of squares, we will be squaring the square root of 2 and therefore getting rid of it, which is what we want to do. So we need to multiply by the conjugate. Okay, so this is 1 plus square root of 2. We're going to multiply by 1 minus the square root of 2. So wherever the radical is, if it is negative, make it positive. If it's positive, make it negative. That's called the conjugate. So if we had a plus b, the conjugate is a minus b. Okay, this is called the conjugate. And the reason we multiply by the conjugate is so we can get a difference of squares. And what's a difference of squares? It would be a squared minus b squared. And this will help us because squaring things will help us get rid of this square root that we have in the denominator. Okay, so we have this in the sense it's like a plus b, and then we're going to multiply by a minus b, so we can get a squared minus b squared. So let me erase this. If we multiply by 1 minus square root of 2 in the bottom, we need to multiply by 1 minus square root of 2 on the top as well. Because remember, we can only multiply by 1 if we don't want to change our fraction. So we're going to multiply this by 1. This is a clever choice of 1. 1 minus square root of 2 over 1 minus square root of 2. Anything over itself is just 1. So we're good. Okay, on the denominator, we get a difference of squares. We get a squared, which is 1 squared, which is 1, minus b squared, and b in this case is square root of 2. So the square root of 2 squared is just 2. Notice no radicals in the denominator. In the numerator, we have 6 times 1 minus the square root of 2. We need to distribute this 6. So distribute the 6, we get 6 minus 6 root 2. And down here we have negative 1. We can distribute the negative 1, okay, to both terms. Distribute the negative 1. So we will have negative 6 plus 6. square root of 2. Now, in this case, we didn't even end up with a denominator, much less a radical in the denominator.